3 o'clock, 9 o'clock, you are live. Hello. Hello, everyone. Jemsen, hello.
Hello. Good afternoon from my side. Good afternoon from Singapore.
From far away. Let me put you on solo layout, Jemsen, because you're the one which is most far away.
Sun rises from the east.
Yeah, that's right. I hope it will arrive here, because at the moment it doesn't look that it's going to arrive. Yeah. Jemsen, great to have you here, and I'm happy, and I want to welcome everyone who is attending this webinar. But first of all, let me also put Thorsten, my dear colleague, here in a little bit a bigger screen.
Thank you.
Thorsten, it's a great pleasure to have you here. And actually, you are here for the second time in our webinars.
Yeah, that's true. So the last time was with Harald Mahler from Siemens, and I was also at this point within the Siemens company. Yeah, and now since 1 month I joined AGT-PSG, and I'm very happy to be here as a part of this great company. And I think that there's a lot of improvements going on at the moment, and I think it's a very interesting journey for all of us.
Yeah, let me use this platform here to really welcome you also in our webinars, and it's a great pleasure. Actually, 1 month and 7 days are already gone, so no. Jemsen, there's some echo. Is that
no? It was coming from my handphone. I switched over. Sorry.
All right. No, that's all right. But everything is working fine so far.
Yeah. It's live.
Great. No, Thorsten, like I said, it's a great honor to have you on board, and it's also great that you can bring your perspective, your knowledge, your experience in our discussion in what we are doing here at the Perfect Sample Gas Company. And therefore, we decided that we would like to have this webinar here as more kind of an internal session, so to say. In the last webinar, I think it was also very impressive to see all the details from Gardner Denver Thomas pumps, the peristaltic pumps, to get so much details and insight. And later on, I will show our upcoming events and our upcoming program. But therefore, I really appreciate that, we have the chance here to look in the near future of CEMS system. So, okay, everyone, welcome. Now let me switch. Oh, that was actually the wrong switch. Yeah, that's how we do it. Jemsen, you are the master of ceremony. Is it? I think we have not agreed.
Let's try our very best from all of us.
Yeah,
I'm the one who prepared the slides, that's for sure.
I know who is the one who is responsible for the title. That's for sure as well. So, future demands in CEMS configurations. I shared on LinkedIn that yesterday I was attending and I had a presentation at the VDI Emission Monitoring Conference. And I must admit, it's always great to come together with so many very experienced people. This is a group of authorities on the one hand side, then the German TÜVs, the TÜV Rheinland, the TÜV Süd is there, and obviously also the leading analyzer manufacturer. And I think it's very important to see the future of continuous emission monitoring. And I think with all the future developments which will be there will be special requirement also in our field, also in our competence. And I think that therefore it was a very good idea to see to look into the future. I mean, no one knows the future for 100% sure, but to see what is current trends and what is developments. And yeah, that's what today's webinar is about. Okay, Jemson, if you can give us the next slide, please. This is the outlook, and yeah, maybe you realize that there's another name I could add. So today we have the future CEMS, what we are going to discuss. Then in 2 weeks from now, and I'm very happy that this very nameful company, KNF, yeah, is attending our webinar. I think that's going to be very interesting because it's a very innovative company. They will show us the newest development, and I think also the field of transportation of probe material or of the probe gases. It's a very important topic, and it's also directly linked to what we are going to discuss here today. We will talk about ATEX, we will talk about special environments, special applications. So I'm excited to have KNF here in 2 weeks. Then, you guys have to be a little bit careful because then 2 weeks later we are going to have nVent, which are known from the heaters which we use in our heated sample lines. So this is the company we are working together with since more than 30 years for the heating cables. Then we have SICK. I think SICK Sensor Intelligence is a very big name. Nothing I need to explain here, and I'm very excited to have Felix and his colleague joining us. Then at the 2nd of December, as you can see, the year turns very fast into an end. We have the company called Schrang, where we talk about enclosures and special protection, cabinets, analyzer container, and these things. And then at the very end, we have Gasmet. And I also think that this is a very famous, very popular name with super interesting technologies. And they give us a general overview, but we will also talk about continuous mercury measurement. And I think this is another very important component in terms of emission monitoring. So, wow, it's a full year, right? Jemson, when are we having our Christmas celebration?
Well, I have prepared, the same thing, the Christmas hat again, the Santa Claus hat for you.
Okay, you prepared one?
No, it's it was it's usual the red hat with the white ball or cotton wool on top.
Yeah, that's right. I think last year I was celebrating this together with Tobias, and we had this green hats. And that was kind of interesting because there were still the boxes. This was the moment when we moved the factories, and we still had the boxes from the move in our bag. Okay, we have to do this for sure. Okay. Next to the possibility to look live or to see the webinars here live, every stream we are going to transfer to our YouTube channel, just for your information. So if you missed one, there's no problem to look it up on YouTube, and you can find all of the webinars there. Okay. So, today's agenda, future demands and applications for CEMS. And therefore, this is the part where Thorsten will share his view on this topic. And then we will also try to link from the future demands and the future developments to the requirements for finally our equipment. And this is also, there we are also going to show what is the latest product innovations and product developments we have. And so to give a feeling how can these topics finally match together. Okay, Thorsten, the stage is yours then.
Yep, thank you very much, Jörg. So just from my personal history or experience, so I'm normally coming more from the process industry side, so from the process itself and not just from the power plant or emission monitoring system. But in any case, I think there's a kind of melting together between the two worlds of emission monitoring and the process industry. And for this reason, it's quite interesting to see where the industry is developing. So one fact, of course, is that the production of energy will stay one of the most important topics in our world. So as we at the moment look, for example, to China, where we see the energy crisis, when we see the demanding or the rising demand of energy in Germany, in Europe, and anywhere else, there's a really big and important issue for production of energy. So this will stay a topic in the future. But what does this mean for us? So this means that more energy, more power plants, more emissions, more masses going up with the different components needs to measure. And for this reason, it's really interesting to have a deep insight into this topic and look at these applications.
Yeah. So, Thorsten, that means, I mean, the energy demand will grow. I think that's for sure. But you think that even, I mean, we call this coal power and gas power plants. So you are relatively certain that even the demand there is growing, right?
Correct. So when we, for example, look at the gas-fired power plants, for example, here in Germany or also in Europe, I think that we have seen that there are a really huge number of new plants which are now developed in Germany and in Europe, and that the energy which is coming from gas itself is really increasing. And what we also see is that coal, as it is not that popular in Germany or in Europe, is still a really good energy driver in the rest of the world. So coal and also gas is still a very interesting energy part. But when we also talk about, let's say, gas, for example, then maybe there will be maybe the impact of hydrogen also here in Germany or also in Europe, where you will put a lot of hydrogen into the natural gas grid, and then you have to burn the hydrogen also with the natural gas itself. So I think there will be a lot of outcomes for not just the emission monitoring systems, but also for the processes. Because when you think about the chemical issues from hydrogen, for example, so the complete gas will change. And this will change the industry in a way that we all do not know at the moment. Yeah.
Absolutely. Jemsen, what is your feeling? What is your experience? I mean, you with being in Asia, I think you have kind of a different perspective. Thorsten already mentioned. I mean, here in Germany, it's agreed that by the end of 2038, all coal-fired power plants will be shut off. Maybe earlier. We are now in the let's say development of our new government. So, but what's the situation in Asia? How do you look at that?
I can clearly speak for Singapore side, which I'm very clear was that we are switching to natural gas. And we do not have natural gas, but we have signed an agreement with Indonesia. It's a long-term supply of natural gas because they have a lot of natural gas field known as Natrunas near to the South China Sea. And we're piping in this natural gas. In fact, it's all started a few years already. So all the power plant, in fact, right now, switching from this heavy fuel oil is already switching all the way towards the natural gas. This is one thing, is significant. Other energy is that we are already had an agreement with Australia to pipe the electricity from Australia to Singapore. Just imagine how the piping from Australia undersea all the way back to Singapore. So
but the energy from Australia then finally comes from coal-fired power plants, because I still believe that Australia is one of the biggest export countries in the world for coal. Huh?
I was told, but I'm not 100% sure.
Yeah.
I was told, and I read article. Not only that, it's because Australia has a big vast of land, and they are using solar energy. Imagine the amount of solar energy that spread across the land in Australia.
Could be, absolutely.
Yeah.
Could be. But Jameson, with all the respect, I mean, Singapore, that's where you are living, but Singapore is not the center of let's say, Asia, and certainly not, and depends of industry power demand. So I think even the situation in China with the energy crisis, what Thorsten already mentioned, is that they are still building new coal-fired power plants. So coal is still one of the.
This is true. This is true. In fact, there are not significant switching at this moment. Coal is still the main source of fossil fuel used around in Southeast Asia.
Yeah. Okay, so when we sum up all of the information, what we just said, so power. No, I think, Jameson, if you stay on the slide before, please. I think production of energy will remain a big topic for emission monitoring. But what Thorsten also said is that it becomes more a mixture of, let's say, the emission monitoring and the process monitoring. Thorsten, is that what you were trying to say?
Yeah, that's quite right. When we think about also the natural gas, one more point about this topic, it's not just that there's one natural gas in Germany or in Europe or in Asia. So there's a lot of different kinds of natural gases. They all have a similar composition, but it differs from time to time and from where the gas is coming from. So there's also LNG, a topic. There's Russian gas. There's Netherlands gas. There's also gas from other countries. So there will be all the time a mixture. And when we look, for example, also in the gas market itself, H2S, COS, and all of these components are included in the natural gas grid. So what does this mean? When we do a combustion for such gas combustion plants in a very big amount, then of course there will be sulfur components inside the emissions. Mm-hmm. And this leads me to the next point with the smaller limit values. So when we have a clear input for a gas turbine, for example, which is the natural gas, but it is combusted in a very big amount, then of course the small pieces of emissions do have a real value for the complete emission monitoring system itself. So this means that the limit values will decrease. So for CO, NO, and all of this, we have seen this kind of development. But also when we talk about SO2, for example. So there are a lot of emissions from SO2 going up in the air, which are not at the moment be regulated here in Germany or in Europe for gas turbines, for example, or for gas combustion plants. But this is still a topic. And when we look at the decreasing amount of or the decreasing limit values for these combustion plants, there will be, let's say, new technologies, new measurement techniques, which will be certified. Maybe we look at chemiluminescence devices or something like this. So there will be a complete new way in looking to these gas applications in the future, I think.
Mm-hmm. And I think, Thorsten, I think that's a very interesting part also for our components. Because what does it mean if you say, and I think this trend, no one will increase any limits. I think that's political, not possible, and I think it's just, it doesn't make any sense. But I mean, this also means not just from a perspective from an analyzer company. I mean, you've been with Siemens before, but also for our components. This means we cannot stop doing R&D, right? So we have to increase also the performance of our products.
Correct. This means a lot for us, because we have to think really about the sample collection. We need to think about how to transport these small amounts of emissions to the analyzer system, and also we need to think about what is going on in the cooler, what is the water washout effect, and focusing on very small amounts or pieces of emission limits. And for this reason, I think the complete chain from the sample point to the analyzer itself needs to be rethink.
Yeah.
And for this reason, I think we are on a very good way when we look also to the washout effects of our MAK20. Jörg, I think you will talk about this later.
Yeah.
And I think there are some things going on at the moment, and I think we are on the right track at this point. Yeah.
Whew. Good for us.
Well, maybe when I go a little bit further, and we not just look at the limit values itself, but in the world there's a rising demand in the next point, which is security, reliability, and safety of the complete measurement system. So when we look, for example, at the boiler control or something like this, I think that X components where you have, let's say the boiler application, which I mentioned, where you have a lot of CO, which will come from the process itself, maybe, you have to secure that there will not be any points which needs, which can make an incineration. Yeah. So for this reason, having X components from the sample probe over the sample, the heated sample line to the measuring cooler, and maybe also the analyzer, will be also a thing that needs to be focused on in the future. Because although the system itself is not implemented in the X zone, but the probe may contain a composition that is X, so we all need to think about how to solve this problem. And I think security, reliability, and safety, like I mentioned, is a key for the complete industry, because people are having more and more things. Also the countries, China and all of these are developing, yeah. And for this reason, I think all people want to have a secure and safe job. And for this reason, any country in the world is looking to these points.
Yeah, I think very interesting to get this kind of external view. I mean, now it's not external anymore, Thorsten, but I think this is interesting from your perspective to see that. Jemson, would you confirm the points?
Yeah, in fact, I mean, we know that we are from the so-called majority of us from the third world. We always take references either from the European community, for example. Like in fact, our environmental ministry, we take actually reference to TUV. In fact, TUV has just set up their branch office, a new building, has just signed up 1 month ago. I'm not sure you saw the big news in Germany or not. But then again, you know, we're taking reference to US as well as Europe to adjust our environmental regulation. So this, you guys are taking a lead. So
yeah, I think that's a big trend as well. I just heard that the TÜV Süd, for example, they have more than 4,000 people just in China. And so I really think that there's an increasing demand of these securities and of audits and of quality assurance. But I think it's great. And I also think that it's a very good opportunity for us to show if we are looking into these developments, and Jimson, now you can probably refer to the next slide. Let's have a look. What is the latest development and what is the biggest demands here? If what Thorsten just mentioned, if these points are a topic. So, Jimson, maybe on the next slide we can have an overview. Or you can just maybe introduce these slides. That would be great.
Yeah. So now speaking from as a system integrator for many years, all right, and building a lot of systems, and so much so that until I joined a gas sampling company like AGT, and that is where I realized that so many mistakes I had, delivered in the past, which I would like to take this chance to share this very valuable experience that accumulated for many years, to put them into a few key things that, for the benefits of the analytical audience here. So many of them is that, as a system integrator, the main systems that we construct are the process analyzer system, right? And many times we were having in mind that, to construct a process analyzer system or design the systems, we implement almost the same structure, the same fundamentals on the flue gas, a CEMS system, right? Which I had done that in the past, and that's where the mistakes lies. So I'd like to point out to you is that in the process gas metrics, they are all product. Mainly they are clean and they are positive pressure. All right, for flue gas, be it in starting from combustion, from DNOx, from FGD, all right, or all the way to CEMS systems, these flue gas are generally has a sample pump, which means they are negative pressure. They need the sample pump to siphon the gas to sample to the analyzer. That makes a big, significant difference when you start to configure a reliable CEMS system. So to put this in a nutshell, I try to say the word condensation. Condensation is the biggest mistake if we are not taken into consideration right from the beginning. Condensation happens in the flue gas systems because remember I said it is negative pressure. Once you created a positive pressure, it means that you are changing the dew point. Once you're changing the dew point, the water presence in the sample will start to condense, and that is where you react with some particles, react with some acid to become corrosion, and it all affects your gas analyzer. So to put all this thing, what I say today is we are not going to talk about the sampling every component. This is a two area which I want you to take a very serious look. Remember now is that whenever you consider to configure a CEMS system, number one is make sure that from the sample probe to the gas cooler, make sure that it is above acid dew point. All right, it must be above acid dew point. Otherwise, it will start to have this corrosion, start to have these blockages, all right, and losses of gases. So another area, we know that there's a pump. The pump is siphoning the negative sample and deliver it to the gas analyzer, is that make sure that you minimize the back pressure, all right? Never put a pressure regulator, never put something whereby you have oversizing a sample pump that you are not able to have a good bypass, creating a back pressure. Once a pump outlet to a gas analyzer there is enough back pressure to create and changes the dew point, that is where all the maintenance you have to address down the road. All right. So this slide will tell you, I repeat, that the red color is telling you that you must above the acid dew point, the blue color making sure that you do not have a back pressure enough to change the acid dew point. Okay.
Jameson, thank you for sharing this and for showing this. And I think if we take this now into the context of what Thorsten just said, with ATEX of measurement of these components in the ATEX environment, I think that's even another challenge and another demand, right? Yeah. Okay. Yeah.
Yeah. So I think there are so many probes which I mentioned earlier in the early days. So much years of system integrator. I always use one sample probe, one heated line, one gas cooler. It's more like a copy and paste, design to fulfill all different CEMS systems, like a one shoe fits all.
Yeah.
All right. So that is where all the problem lies. We do not know what we don't know. We always say that we saw the horizon. We thought we have seen everything. All right. So this is some area whereby it is so important that the sample probe is not just a probe that you handle the gas. There are so many things has to take it into considerations, such as the material, such as the amount of calibration gas flow that you do not want to waste, all right, which is unenvironmental. You do not want to climb up the stacks to change the filter if it is unnecessary. You making sure that your acid dew point is handled, is hot enough without cold spot. You make sure that the process is maybe 500 degrees. How can my sample probe, which is 180 degrees, able to adapt to the 500 degrees process? All this has so much mistakes that I make. But to put that all together, the first thing that, that's the most common, it is really so much things to share. The most common thing I like to share with the audience here is the filter element. The filter element is so important that you can look at these slides that on one hand is called the homogeneous filter element, which is same porosity. Let's say a 5 micron, 10 micron, 2 micron. All right, it's a homogeneous filter porosity. On the other hand, you can look at...
I think, Jameson, sorry to kind of disturb you in between. I think this is also important to understand. Thorsten just mentioned safety is one of the main points from his perspective, but also reliability. Now, if we remember the PNID you just shared, Jameson, and we consider now that the filter element, I mean, especially in the application gas-fired power plants, what Thorsten just mentioned, the number of dust is not very high, but still there is some dust. And as soon as you get some blockage, and this happens obviously faster when you have a smaller filter element, the entire emission monitoring system is changing because of different pressure situations, right? That means if the filter is blocked, you have another pressure. This, depending on your analyzer technology, when you're in a cold extractive system, this will also change the outlet dew point or can affect the outlet dew point. And this at the end then can change the reliability of the measurement you are doing. I think technically we call it a drift, yeah, which means by the operation of the monitoring system and due to changes of the probe sampling, you will get different analyzer results. Also something we should mention here, because this probably also shows how all these different things, are harmonized or how they stick together. Huh?
One more point, Jörg. So when we talk about a big filter surface, also when we look at gas-fired power plants, for example, might be a plus, because you do not need to do the maintenance that often, like when the filter element is a little bit lower. So as bigger the filter element itself it is, then of course you do not need to make so much maintenance at this. So maybe it's possible to exchange the maintenance interval from 1.5 year to 1 year or something like this.
Yeah.
And when we talk about maintenance cost and people getting more and more less in the industry, then of course maintenance is a big issue. And
And I really like to pick up your thought there, Thorsten. When we talk about ATEX, I mean, if I would be the responsible manager, for the responsible plant manager, and we would have measurements, which you just mentioned, with mixed gases and with mixed gas matrix in the gas power plant, for example, if it's a measurement in the ATEX area, or if the gas we are measuring could be explosive, I think it's very natural that every responsible manager would try to reduce the times where his personnel and his staff has to be in contact in this area, is as much reduced as possible, right?
Correct, yeah.
Yeah.
So because when you go to an ATEX area, for example, you have to have the permission to do the work. Yeah, right. There's a lot of preparation to do the work, and for this reason, when you have a big filter surface or a reliable measurement, and you do not need to go upstairs and go to the sample probe itself. So this is really benefits when we talk about X applications. Yeah.
Yeah. So then let us use here the PSG Plus, the ATEX version of our PSG Plus probe. Jemison, I think the next slide helped me. Is that where we put it, where we integrated the video? Not sure if we. That was. This is the animation. Let's see if it's working. And I think we shared this video also before. It just shows the efficiency of the back purging. I think it really gives an impressive outlook. But now let me do the following. Let me just try to show it or our ATEX probe solution here a little bit bigger. Because what our team managed to do here is the following. We managed to have a self-regulating probe within the version, as you can see it here, with 2 heating cartridges. And these 2 heating cartridges allow to reach a holding temperature of 180 degrees C. Jensen, you just mentioned about the acid dew point. Depending on the gas, gas components and the mixture of gas components, it could be that there is a very high acid dew point, and it's even needed that the heating will be higher than this 150 degrees C. In terms we need only 150 degrees C, we can leave away 1 heating cartridge, so then we are good with just 1. But if we need to reach the 180 degrees C, this is the solution. And allow me also to outline that we are quite proud. As you can imagine, this is not a very easy development to hold this high temperature, especially when you have such a big probe, and when you have this big filter surface. And we wanted to make sure that in our development, we remain with our core, let's say, advantages, and that we were able to develop this very good new solution here.
Yeah, maybe Jörg, one more point to add there. The art for designing this kind of probe was also to reach the T3 level, so that we can put it in the Arctic zone with a T3 level. And this is not that easy to reach in a kind of ARTEX certification, because the temperature itself is so close to the things that needs to be fulfilled in such a certification, that it was not that easy. And having T3 with a 180 degrees probe is really good, I think. Yeah.
Yeah, and I think we are done here. It's also nice to show the housing because we have a very high IP protection class, and this also allows us to reach this 180 degrees C temperature when the ambient temperature is minus 40 degrees C. So yeah, I think that's pretty nice, and I think it's a good development in this field. Okay, so Jemson, if you can, I think I'm the one who has to put back the presentation again. I hit the wrong button. Okay, could you shortly take over, Jemson?
Yeah. So you can see that, of course, the probe itself is not ended. There are the next component, the heated sample line. Yeah. So I mean, again, I like to share my practical bad experience, those mistakes that I have made, right? So I like to share with you not to make the same mistake that I have done it in the past. Is that, the heated line is something like a black hose that many people are blinded, especially the end user. They have no idea what are the hoses that they are buying. It's just a black hose. So many of the times that the questions about the heated line is there are different material, right? Different prices, especially. It is coming from a very, very economical price and all the way to the much more premium prices. And it all seems to be performing the same thing, right? This is where, I got it all wrong until I have to do the whole installation. I realized that things that I have not considered what it is so important is the wrapping. All right, when we do the banding of the heated line, and there are chances that the heater and the heating inner tube will be started to be going apart, and they are not able to hold the temperature, and things like the material itself when coming to banding into the analyzer house, right? So the banding radius that available in the market has approximately 6 to 8 times the external diameter of the heated line. All right, I repeat, 6 to 8 times. These are very, very conventional, which means if you are to bend it a little bit more, there is a possibility of damaging the heater element itself inside the heater line, which you can't see for yourself. So what is that is available in the market, all right, is that there are heated line with heated, whereby it is much more flexible. It's much more flexible. Same material. Why it is much more flexible? Where this comes to about the intellectual property. So you can see from these slides, you can see 3 different types of heated line. The one on the below, all right, the radius banding has a much bigger banding radius. These are very traditional. You can easily run on the cable tray. Imagine if they have a right angle cable tray, you start to have a problem. Not to mention if it goes into the analyzer house, right? So you can see that the other two, these are something that is quite exclusive from us, right? Whereby we can band a much smaller radius to avoid things like breakage of the element, damaging inside.
I can maybe show here. Yeah, this is the extruded flex line. But let's say, Jemson, this is just a comfort level, so to say. But I think the important part here also, with the background of what Thorsten mentioned and introduced, the safety aspect, I think that's a very important aspect as well. And I think it's great that we just give a short overview. I mean, because it is special for the installation, and maybe in the next slide you can shortly share this with us, Jimson, because there's some do's and some don'ts in the installation of a heated line. This is an information we always share when we ship our equipment there, but bending radius is one thing which is mentioned. Then the distance from heated line to heated line is a problem, can be a problem. And therefore, it's another advantage that in certain types of our lines, you can cut. So you can cut to the right length. And I really think that this can be an important advantage on site. And at the same time, also something we mentioned in many webinars already is that with our ATEX heated lines, we can deliver the full certificate. So if we see here, or if we look at this overview, we start from the so-called standard ATEX line. This would be a line how it's recently many times produced. And this line comes with a certification for the heater, for the heating element. Then we have the AX2 line, and the AX2 line has a special architecture which allows to avoid dangerous electrostatical load, especially from the outside of the line. And this is what we do with this aluminium foil. And then the latest development, so to say, is then really a conductive jacket, because this one, Thorsten, I think I always say that wrong, but this one is applicable also for the area to see, for the ATEX area to see, right? And this one is limited in this case, right?
Correct, yeah. So I think you just said one very important point also for the ATEX areas. So when we talk about ATEX sample lines, they are a lot more expensive than the normal non-X lines. And for this reason, this cut-to-length technology is quite an important point, where you can say, okay, you will just shorten the ATEX line to the length that you really need in your plant. So when we talk about, let's say, also mega projects in the world, and you want to have certain kinds of measuring line, then you can order, let's say, up to 1 kilometer or more of the line, and then you can cut it for the ATEX zone into the length that you want to have. Yeah, and this is a really good thing.
Yeah, another very big advantage. Okay, probes. I think we proved that there's a safety solution, a safety and reliable solution. Heated lines, just the short outlook. I mean, like I said, we did already some webinars about that. And now it comes to the field of gas cooler and gas conditioning system. And I think there's two areas. The one area is when the ATEX cooler or the conditioning system is directly installed in an ATEX environment. But I think, Thorsten, usually in the application, the companies or the operator would try to make a safe room or a safe house or however, so that the cooler itself would not need an ATEX certificate.
Correct. So when we talk about the ATEX zones, it will be most of the time at the sample probe and the heated sample line, because it's maybe going through the ATEX area. But most of the time, the plant operators do their emission monitoring systems. When we stay at this example, somewhere where there's no ATEX zone. But in any case, when we talk about the process industry, for example, then the ATEX things are really important. And for this reason, also the cooling units of BCR are really important for this area for industrial cooling units.
Yeah, I think I can shortly show this here. This is our, we always say the big boy. This is the BCR05 cooler, which can be used even in ATEX Zone 1. And I think in the last webinars, we also showed and shared the solution we have there for the ATEX Zone 2. Just to say or to show that there is a solution. At the same time, I think we also discussed and we talked about lower detection limits, Thorsten. And maybe it's important to say that the analyzer system, the CEMS system, at least in Europe, is looked at as a complete package. That means we have the sample handling system, the probe, the heated line, the cooler, other accessories which are needed for the probe sampling, and the analyzer, and all together is measured. We will, by the way, have another webinar with the TÜV Süd, and I'm very excited so that these guys can explain us the European way of qualifying the equipment. I think it's very interesting and to see that. But that also means we have to do something in order to reduce or to optimize, so to say, the SO2 loss, which happens in the cooler.
But maybe one more point to add there, Jörg. So when I would think about having a complete emission monitoring system that goes into the certification for the EN 15267 or also MCerts, I would also think about what is the future, what is going on in the future, because the certification is lasting a long time. And when we then look at the future and we think about washout effects, smattering measurement values and all of this, then of course you need also to think about the cooler. And as you are focusing on the cooler, you will have the opportunity to measure smaller amounts of, let's say, SO2, NO2, or also CO is not a washout effect, but you can really measure smaller amounts of emission components. And if you do not look at this point, then of course you might lose your focus for this kind in the future. And this is a very important topic, I think, to focus on.
Yeah. Okay, so then let me just shortly show Jemsen or introduce a little bit more formal our newest development in this field. When the MAK20, Jemsen, I think the last slide we have was one slide which really shows it. By the way, guys, that's kind of interesting. We said at the beginning, okay, maybe this webinar only takes 30 minutes. It will be shorter than the other one. I told you at the end we have to rush. It's always the same. It's always the same. No, but I think it's again very enjoyable. Hope for the audience as well. The MAK20. This is exactly what Thorsten mentioned. So we see new requirements or changed requirements upcoming. Back in the days, I think the volume, this is the right word, the flow which was needed for the analyzer system, Thorsten, was way higher, right?
Yeah, it depends on the T90 time of the complete system, because when we talk about the certification, you need to have a cut at the T90 time of, I think, 200 seconds for cold extractive systems or something like this. And for this reason, as longer the measuring lines are, the more you have to the more flow you need to have in the sample system, and you are just pushing it over a fast loop or something like this, and the rest is going over the analyzer itself. Yeah.
But is it also true that, I mean, the older version of analyzer, they just needed more flow?
I'm not really sure about this topic. I would say, when I think back about the analyzers that I have sold so far, I think there was not that big change going on in the
Okay.
last years, and I think the flow has stayed the same. So when we look at, let's say, cold extractive system, I do not see that change. When we look at hot extractive system, maybe there was some kind of change, yeah.
Okay.
Yeah.
Okay.
Yeah.
Yeah, but anyways, what we developed here, and you see the two brothers standing next to each other, and from this perspective, at least from your perspective, I think it's hard to tell if there is any difference. But there is a difference, and this difference I would like to show you. I mean, the MAK 10, which you can see here, has the patented heat exchanger inside. And we know that it comes with a very reliable outlet Dewpoint, but it was our task when we developed the MAK 20, which you can see here, to decrease the washout rate. And the number we managed this is something we would like to show you more in the when we have the diagram in the presentation. But just from the outside to tell you a little bit the difference. I mean, the MAK 10 system was concepted and was designed in order to become a full conditioning system. That means with many options. You can have the gas sampling pump inside, you can have a flow meter, you can have a depth filter, you can have many different options integrated. And we are very happy that we managed to do the same with the MAK 20. The big change is, because sometimes we heard that, the customer said, oh, we have no direct access to the heat exchanger. And this is something we changed here. So just to show you, this is the new designed jet stream heat exchanger. Oh, I have to, it takes a little bit of time. So this is the new design we have here. And it's easy to change the heat exchanger if needed without removing any screws in the housing of the cooler. This is for sure one big advantage. And what you can do at the same time, you can still operate it when it's. I think I have to move a little bit. You can still operate the cooler when it stands, but you will also have direct access to the condensate out from the heat exchanger from outside the box. So I think this is one of the most obvious changes you can see here. So all the other characteristics and all the other advantages of the MAK 10 remain the same with the MAK 20. So you can have a docking station, so you can extend the cooler, and we have all of these different options available with the cooler. And you are not losing any of these options. I think that's a big advantage as well. We also have an interface option in order to transport the outlet Dewpoint temperature. This is another big advantage of this solution. And as you can see here, you can either, depending on your flow rate, you can either operate with one heat exchanger or you would have two heat exchanger. In this case, you would connect the first heat exchanger with the second heat exchanger. And this is the difference there. Okay. Yeah, let me just shortly switch back to the facts which we managed to get. So that's probably a little bit small when we compare the washout rate with our competitors. A direct comparison of washout rate is very difficult because the measurement is not easy. And also, if someone will tell you, okay, the washout rate of our cooler is 1% or 2% or 1.5% or 10%, it doesn't matter. These numbers are always very hard to believe, because we always have to see what was the humidity, so the inlet dew point, for example, which you had in this measurements. And as you can see here, we did different measurements with different inlet dew points, and then you can measure the performance and the SO2 loss. And what I can say here is that in average, in comparison to our competition, we managed to reduce the washout effect roughly 20 to 25%. So that's a big development, I would say, and that will really help the analyzer companies when they use this solution, to reduce their detection levels. I think that's that is important for us to mention. Okay, anything I explained wrong?
No, everything is fine. If I given a chance, I'd like to emphasize the word you use, constant stable dew point. Just in case people were to say, why, there are a gas cooler that people are buying from the market. It ranges from a very economical to a very expensive one. And this is the answer to your questions or your doubt is like this. A good gas cooler, the outcome of the sample cooling has to be stable and reliable dew point. This is so important for your gas calibration. It's so important that impact your washout. It is so important whereby we talk about repeatability, reproducibility, and all this encompass to one thing. All right, a gas cooler is able to produce a constant, stable outlet dew point. Thank you.
All right, okay, guys. Like I said, 2 minutes past 10, at least here in Germany. I must say I really enjoyed this. Not just having the first webinar with Thorsten. Jemson, I think we have to do a celebration. I think at the end of this year, we will have 40 webinars finished, 40. Wow. That's quite a lot. That's quite a lot. No, but I really appreciate it, and I really want to thank everyone for watching. I want to thank Tobias, who is in the background, answering all your questions. And be warm invited to our next webinar when we have the guys from KNF here. And I think, Thorsten, one topic I'm going to ask them is about the T90 time, because I think that there's a direct connection, the gas sampling pump and the flow rate in the probe sampling system, right?
That's true. And the T90 time is not just about emission monitoring, where you need to meet certain requirements, but it's also about the process industry, where you need, for example, fast O2 measurements for innertization processes or something like this. So having a good and reliable T90 time and good pumps with a lot of volume flow inside, so this is a great point to discuss the next time about.
Okay, all right, guys, thank you so much. Stay safe. Have a good time, and
you too.
Bye.
Bye-bye.